Let's go through LeetCode 894, all possible full binary tree. For this question, it gives us an integer in the return. Let's compose all of the full binary tree with these n nodes and return a list of all of these trees. And you can return in any order. A full binary tree is defined as a binary tree where each node has 0 or 2 children. You cannot have just one children. So there is difference between full binary tree and a complete binary tree. Complete binary tree is that every node, every layer must be full, right? So that is complete. Complete for layer 2. This layer had to, the next layer will be full, that this is complete. But for full, it's possible. Some kind of nodes, it just have 0, right? And we need to compose all of the binary tree and return the list of binary tree nodes. So for this question, what we're thinking about is that first thing we're thinking about is that this n must be an odd number, right? Because, for example, this is 1, right? And if it has child, it will be left and right? Should be 3. And every time initially it is 1. Every time we add 2, right? So it's impossible every node we just add 1. So those kind of tree nodes must be an odd number. So that means that if this is even, it will return empty list. And the second thing is that, for example, there are n, right? Assume for this child, so this child will also be an odd number. It used 1, 3, 5 until of course not n, right? So n minus 2, right? Goes to this kind of, because this one use 1, right? For this one, what it will be? It will be the n minus 1, right? Because this has been used 1 minus I. So it will be this counts. So the thing is that, of course, we can try to see for every I in this kind of range, trying to compose a list of tree nodes, right? And for every I in this kind of, for every I in this one, we know we get the corresponding count in its right? Also get a list. Then what we do is that we just use a compose the list of nodes here and the list of nodes here, iterate, right? Try to use the two for loop to compose its parents. So this will be the concept how to do it. And when we iterate to its parents, there is duplicate calculations. For example, if we choose 3 here, so this will be n minus 1 minus 3. And possibly, when we iterate in these children, we select 3 again, right? So this 3 and this 3 will be multiple calculations. So for duplicate calculations, normally what we can do is that we use something to store it, right? Store this kind of, for example, 3, we store a list of tree node. So we can think about use some kind of memo to store it, right? So for memo, here, what kind of data structure we can use? We can use a map. Integer will be how many nodes we have. The value will be a list of tree nodes, right? So if it is we compose an I tree from a list of tree nodes from number I, we first check if in the memo we have this I saved already. It already saved. We just retrieve from the map. So let's write code for this, right? We need a memo. List node. memo equals new tree, new hash map. And we DFS n in memo, right? Just return, right? Because for this DFS, we return the list, private list tree node DFS and int n and map integer list of tree node memo, right? So we'll say if this n is an even number, right? So what we do is that we just need to return a new empty array list. Otherwise, what we do is that here is the one of the exit conditions, n equals 1. What we do is that return list of new tree node there. In that let's just say if memo contains key and return memo get and so we are going to have list of tree node result equals new array list. And let's iterate the left child, right, for int I equals 1, I smaller than n, I plus equal to 2, right? Here, every time we plus equal to 2, right? Because every time we can add only 2 nodes. So we'll say lift tree node L result, right, equals DFS and for example left, that is I memo, and list tree node right result, right, equals DFS n minus 1, right? Because the root we already use the 1 node minus I mem. So what we do is that there is a constructor method tree node value left, right. So what we do is that for every tree node in left result, for every tree node right in right result, right? Then we are going to result should add new tree node 0 left right. And we need to put this into memo, right? So that we save it, put and result, return result. The time complexity for this one, because for every node, it has options 0 or 2, right? And so it is like a binary tree. So and when it goes to the left, it has also the choice 0 or 2, right? So it will be 2 power to the power n space right map is on. And let's write the Python code for this as well. So Python code will be similar. We need memo is a map, right? And return DFS and memo. So we define this def DFS. So we need n as the int and the memo. This is a dict int and the list of tree node, and it returns list of tree node. So we'll say if this A mod 2 equals 0, right? Return empty list. If N equals 1, right? We return node 0. And then if N in memo, then return memo, and then we iterate result equals this. And for I in range 1 to N 2, right? So we'll see left result equals DFS I memo. Right result equals DFS N minus 1 minus I memo. And what do we do is that for left in left result, for right in right result, right? Result should append G node 0 left right, right. And in the end, we of course we need to save it. Memo N equals result return result. Right?